There's a new product that I really like in the market by our friends at PowerCast. They created Nintendo Switch grips that you can charge by placing it near their transmitter without having to set it down on a pad or having to plug it in. So the reason I love this is because RF has a ton of potential, but it has to be in the right area. It has to find its niche. I think RF has a lot of potential for obviously small power devices, for things that need tens of milliwatts or hundreds of milliwatts. And those switch grips are a great example of low power devices where the user gets the benefit of putting it near the transmitter instead of putting it down on the transmitter. And we know that it's not really, RF is not really going to replace inductive charging. It's not going to really replace plug-in charging because it's just not physically capable of doing watts of power to multiple devices over a few feet of distance. I think a lot of those early claims have gone away. In fact, if you talk to the people at PowerCast, they wouldn't claim that they could do that. But what they did is they brought a real cool product with the Nintendo Switch grips using the PowerCast charger to the market, showed a really cool niche application where gamers, users can get the benefit of that application by using their technology. So I thought that was a really cool product this year.
I think there's a lot of trade-offs between sort of spatial freedom and the ability to charge at lower rates. So once you get to the below 100 milliwatt range, and especially in the tens of milliwatts, it's an area that RF can really shine. And I think, like I say, I agree. I think PowerCast found a really good application for that. So now you have something that, from a user standpoint, you're not worried about, like I say, you don't have to worry about watts of power, but you can worry about charging smaller devices and taking advantage of the spatial freedom advantage of that RF can offer. And it's a good way of, mixing chocolate and peanut butter together and getting a good solution.
Yeah, can you talk about just the practical limitations? Just where does RF really top out, Jim?
Well, part of the problem with RF is you hit limits with the amount of power you can actually radiate before you start running into maximum permissible exposure limits, and those wind up being concerns from a health effect that the FCC is looking at. So once you get more than about 4 or 5 watts of transmitted power, you try to make it directional as you can, but you can't go much below that. Once you're transmitting that, you're governed by the inverse square law, which every time that distance doubles, you get 1/4 of the energy at the receive side. So as a result, it kind of limits the upside of what you can do for wireless power. So a lot of those early claims of, coming home and dropping your phone on the kitchen counter, and then there's magically some device that's mounted on the ceiling or on a wall somewhere that's going to beam, watts of power, just isn't going to happen. But something like what PowerCast did, where you're really delivering, tens to 100 milliwatts, is something that's feasible depending on how far away you put it, but it allows a greater amount of spatial freedom.
Great. So just as a basic rule of thumb, from a magnitudinal perspective, maybe at 1 foot, you could get 100 milliwatts. At 3 feet, you could get 10 milliwatts. And then if you get along longer than 3 feet, well, first of all, I don't think there's FCC clearance on that yet, but even practically, I think you're dropping down into the microwatt level once you get outside of 3 feet. Does that seem pretty accurate to you, magnitudinally?
That's a good rule of thumb, yeah.
Anything else on your list that you really liked from the industry breakthroughs in 2020?
Well, just recently, the USI has adopted NFC direct charge as their standard for being able to charge styluses. And once again, it's one more thing where you're trying to get a standard on something that may, slide from one manufacturer to another. To get some method of universal charging is important. So that's another step that moved forward in 2020. I thought that was an important development. It was small, but again, I think it was important to move the ball forward.
Yeah, we've talked about the USI adoption in the past, and I agree that that was it's not a product, but that's a real industry breakthrough when you have a group of leading companies coming together and adopting a singular way of charging. So that's really exciting. The last thing I wanted to point to for 2020 was the adoption of, again, NFC direct charge. There's a real theme here, but the adoption of NFC direct charge by Huawei in their Gentle Monster glasses that they announced in the early spring of 2020. Now, I haven't used the glasses. I've put them on my face and I've charged them and I've kind of felt them. And I'm not speaking for the user experience of the glasses because my understanding from reviews that is pretty limited right now. But I think what Huawei did was release a little bit of a concept car, or in this case, concept glasses, to show what's going to be possible. They're actually pretty stylish. They look pretty cool. Most importantly to me, they have a really cool user experience when it comes to charging. You drop your glasses in the case. There's no ugly pins on them. There's no pins that can get damaged. Everything's inside the plastic using NFC Direct Charge. You drop the glasses in the case. Regardless of which arm folds, it should charge. So I think that that's the way that all these AR, VR glasses are going to be charging in the future in their carrying case without pins. And I was just real excited to see a real industry giant develop the Huawei monsters with NFC direct charge in them.
Yeah, and I think they're taking an advantage of one of the real powers of the NFC direct charge ecosystem, where you can allow for much smaller coil sizes. You still maintain a range of good spatial freedom, or at least acceptable spatial freedom, to allow a level of variability in the placement of the device. But it's something that she really doesn't offer right now, where it's kind of limited to a physical size of the transmit coil, and the receive coil has to generally match up in size with it. So for something that's going to have a very small size, like a receiver coil that's going to be in the actual frame of the glasses, this is a totally enabling technology for a whole new range of small devices. And I think that's the real promise you're going to see in a whole range of different products. From again, these types of virtual reality glasses, you're going to see them in fitness trackers, smartwatches, all sorts of things are going to be able to take advantage of NFC to handle their charging and maintain it from a good user experience, or industrial design.
Yeah, and I'll also remind you and anyone that's watching this that we spent a good amount of time at another time talking about how those small devices you're talking about will be able to charge on the backs of phones, which is really cool. Basically, you'll always have your charger with you as long as you have your phone. So I think that this whole ecosystem is going to blow up in a good way.